Hey everyone, my name is Hari. I am the CEO of Cantina. We are an industry-leading cybersecurity company. We started the company after me and my co-founder um, saw this acute problem in the crypto industry after working at the Ethereum Foundation and building the Solidity language. And we decided to start a cybersecurity company to go and fix some of the security issues that we saw in the market. And we work with customers such as Coinbase, Uniswap, and you name it. Today, I have a wonderful guest, Alexis from Coinbase. Alexis, do you want to give an introduction?
Yeah, sure. So, hey everyone, I'm Alexis Williams. I'm a staff blockchain security engineer at Coinbase, and I'm on the protocol security team at Coinbase. So, that is the security team that is basically in charge of all of the on-chain and like smart contract related security at Coinbase, which includes the on-chain bug bounty program that we host with Cantina.
Coinbase has one of the largest bug bounty programs among large publicly traded companies. Even companies like Apple, which tends to be a company that prides itself in safety and privacy, their max bug bounty is $1 million to $2 million. Coinbase has a pretty big bug bounty program where the maximum payout is at a $5 million. Um, Tell me a bit about why did you decide to even launch a bug bounty program?
Sure. So, to us, we've always had like the HackerOne bounty program, right? And that was kind of the place that we were kind of, aggregating both like off-chain, bugs reports and like on-chain bug reports. And what we realized is that kind of aggregating them together kind of maybe made it difficult, right? It made it difficult to triage. We had multiple teams that had to go through the same intake. And then also, in general, besides like the process and operation standpoint, right? Smart contract security is really, really important. And that's something that we want to emphasize, right? And especially another thing that we acknowledged was that, the bug bounty payouts and the scale and the size and the magnitude versus like your standard Web 2 bug bounty program versus a Web 3 bug bounty program, right, is much larger. And that's something that we wanted to properly reflect and show, right, in our importance, right? It's one thing to say that smart contract security and on-chain security is important. It's another thing for us to actually, take action and, create a whole new bug bounty program and increase, the rewards and make sure that all of our smart contracts are in scope. So that was something that we just really wanted to make sure people knew and that they had access to.
That's awesome. So one thing we want to get right away is Cantina recently launched this product feature where any bug bounty program or any competition can optionally request security services to stake a deposit uh, while they're submitting a finding. And Coinbase, in particular, wanted to make it fully open to everyone to submit without staking anything. Um, I want to understand from your point of view why you made that decision. What makes Coinbase want to open up the bug bounty program to anyone in the world?
Yeah, for sure. So I think first and foremost, we wanted to make sure our bug bounty program was accessible to all researchers because as we all know with smart contracts, right, it really only takes a single bug, right, to absolutely be wrecked in your protocol, right? And a lot of times what we realize, right, with our external programs, right, is that people are going to go after the things that we consider to be like unknown unknowns, right? We don't know what the risk will be, and we don't know what the impact will be, right? And so to try and kind of add, restrictions or maybe make it such that certain people, wouldn't want to participate or add friction there, that's not really something that we wanted to do, considering that we're working with unknown unknowns and we're really not sure, right, who the person, who's going to be the person that basically finds like a critical, vulnerability in our smart contracts. So that was like the first piece of it, right? It's just from like a risk standpoint, right? We don't want to change our, probabilities when we're considering risks that we're not entirely sure of how they're going to present themselves and how they're going to exist in our systems currently. But we are certain that there are bugs in our existing systems, right? As there are bugs in every software, you just don't know, right? The curve goes on infinitely in terms of bugs in your programs, right? And then another piece that I think is maybe more like a company specific thing is that, and maybe just like a large company problem, right? But Coinbase is a very large company, right? And so we have a lot of teams and a lot of, externally facing teams. We have developer advocates, we have, people, like just Pollock that have, their own big cultivated, following. We have, Discord servers, we have people go to conferences, we have people talk at conferences, right? And so what ends up happening is that we get a lot of, we call them security tips, right? A lot of security tips will propagate to us from our like different cross-functional teams at Coinbase. And so what we end up doing is we funnel all of these security tips to our respective bug bounty programs, right? You get an off-chain tip, have them issue a report into HackerOne. On-chain goes to Cantina, right? And so something that we were concerned about, right, is that through this system, we're actually able to create like a pretty great like security funnel, right? We're able to triage effectively. We don't have fragmentation. The amount of time it takes to communicate with somebody goes a lot quicker because now they're communicating directly to the security team and not playing telephone through a cross-functional team partner, right? And so that creates a nice security funnel. But if our concern was that if we added this sort of deposit, right, that people would then be more incentivized to maybe push harder on our cross-functional teams, right? So instead of, them willingly obliging and going to our bug bounty programs, they would actually say, no, actually, you have a restriction in your program. I don't want to put $50 or however much right down. And so can you just, this one time, can you just send this to the security team for me, right? And so effectively that like punches a hole in our security funnel and it makes it less effective overall. And so again, more specific to our company perhaps, but that was something that we were very mindful of, is that we don't want to shift that burden and we don't want to end up with a less effective security funnel overall.
That's a great way to put how your organization think about security. And I think this is something that I wish many teams are able to achieve as well, where you just funnel every piece of information that comes your way, and at the end of the day, like we all learn from a new piece of information, whether it's valid or not. I've learned a lot from bugs that turned out to be invalid, and I think looking at every new security tip as a learning exercise is an awesome way to think about your bug bounty program.
Yep, for
I
sure.
also,
and sorry, just one other point on this is that like another piece is that we truly believe that there are actually more opportunities to like reduce the toil, right, in terms of triaging right now, especially within like smart contract security, right? We actually have like a very focused kind of setup for the reports, right? Proof of concepts are generally written in Solidity. And so we think there are a lot of opportunities to do things like static analysis, right? And actually, use like something like Sliver, right? To actually go in and actually be able to mark out like where pieces would actually be invalid. So like maybe marking for like foundry cheat codes, right? Things that aren't going to work in like the actual EVM environment. And then also maybe looking at things like LLMs to reason about like mocks and stuff like that. So we also think there's a lot of opportunities for automation that haven't been explored yet that we think could reduce toil overall.
Yes, 100%. This is something we are working on. We have an internal tool which we call as the Judger, which is an automated AI-based triager, and it's surprisingly good. And we rolled it out for a few internal competitions that are low risk. That's how we think about rolling new products to programs. We always start with low risk items that are not launched on mainnet, and then once we build enough confidence in our tools, we just deploy them to wider programs. So this is something that is like we couldn't have built this product a year ago because LLMs and the underlying tools have gotten a lot better in the last 6 to 12 months. So this is well underway. I think we should be able to build an AI judger that is possibly better than a human. This is an interesting technological breakthrough on the side. I also really like how how you think about like making the program a lot more accessible to like anyone in the world. Um, and maybe this is a wider point that you can help people understand so they can be better security researchers and submit better findings right away. When you get a finding, how do you try to understand whether that finding is valid or not inside Coinbase? How do you try to reproduce the bug? How do you try to check if this is correct and what is the impact of it? So let's say you get a bug that is triaged by a triager, or you just like happen to read a bug that just came in um, all of a sudden. How do you figure out as a security engineer inside Coinbase whether this bug is valid or not, and if it's valid, what is the impact of it?
For sure. And so I can start maybe with like the context side of this first. And so I think something that we don't actually talk about a whole lot, or maybe it's just overlooked, is that the protocol security team at Coinbase is made up, I would say majority, like greater than 90% of all the team members on the team basically have a smart contract auditing background, right? So we have people that come from major auditing firms. We have people that have started their own audit companies, solo auditors, people that have participated in competitions, right? We even have like a PhD level cryptographer on the team. So we're packing in terms of skill and ability, and we use that to our full benefit actually when we're launching new protocols that are going to have like smart contract related components in them, because every smart contract that we have before it goes to an external audit, it actually goes through an internal audit. So we're basically using the like auditing muscles that we have intentionally like gone out and hired people that have to basically work those smart contract auditing muscles and basically get their own internal audit. And so the thing that ends up being really beneficial from that is that we end up having a lot of security engineers that have context into all of our protocols, right? So we're able to kind of effectively triage, I would say like 80, 90%, right? 95% of all of the things and checking validity before we actually send them off to the developers. And so that's like a really great thing that we have from like a domain knowledge perspective. And then back to like the reproducibility point of it is that like really what we're looking at in terms of reproducibility is like your proof of concept, right? Like when people are exploiting smart contracts on chain, effectively what they have is a piece of software, right? That's actually going to go in and do the exploit. And so the proof of concept is like the most similar sort of thing, right? They expect like it's functionally effectively an exploit, except it's on a fork and it's not actually going to, exploit our smart contracts for real, right? And so what we do is using our kind of smart contract auditing background is that we kind of assess these proof of concepts really in the same way that we would any piece of like smart contract, right? Because like I mentioned earlier, most of our proof of concepts are written in Solidity, right? They use Foundry and they write them in Solidity, and it makes it really easy to review. But it also means that we can kind of go through it and not just kind of take it at face value, right? Because I think at this point, every like report that has been like escalated to us from the initial triaging stage has had what would appear to be valid, proof of concept, right? But as we kind of dig into it, we can kind of often find pieces where there are assumptions being made about the system that are invalid, or maybe there's, the way that they're using Foundry's cheat codes, or maybe the way that they're mocking out important pieces of the smart contract logic actually don't, turn out to be valid, when we think about it as a whole, right? Like as we basically take their proof of concept and we stick it back into our system and look at it holistically, we can oftentimes figure out where there might be issues. And then the last point is that on very rare occasions, right, if we have a report and we think it's really feasible, right, and we're not entirely sure the proof of concept is looking pretty solid, but we still think there are some issues, right, instead of just like writing that out, we will actually write what we call like a counter proof of concept to actually go through the entire flow and kind of prove it to ourselves, right, and say, okay, definitively, we're 100% certain at this point that, when we operate the system, at the entry point, we go through it to the expected entry point that we're not seeing that condition that's being, that's in the report effectively.
I love this. For security researchers listening, my takeaway is proof of concept. So focus on the proof of concept when you are submitting a security finding to Coinbase or to any other bug bounty program That's going to radically change how your finding is being looked at, and also for Coinbase as well. It allows them to understand issues faster, respond to them faster, and build safer software for everyone. And with the on-chain assets, what's really beautiful about Foundry is that it's very easy to build these proof of concepts with a few simple steps, which is not often possible in like the Web2 assets, or like in Web2 security. It's not often possible to fork a database of an on-chain of an off-chain software and show it to the customer that, hey, this is a way you can hack your protocol without actually, or a product without actually hacking it yourself. So Foundry really allows you to, first of all, fork a state, and then take a couple of actions, and at the end show it to Cantina, the triagers, and to your customer that, hey, here's how we can do a malicious action without this ever going into the public. So definitely double down on your proof of concept, spend more time on your proof of concept, try to keep your writing, in my opinion, to be quite simple. Most bugs can be explained, in my opinion, in less than 150 words, which is around 5 lines. So try your best to explain what's going on in 5 lines and make your proof of concept do a lot of the heavy lifting that you have to do. So expanding more into proof of concepts, from your point of view, what are some tips that secure researchers can do that makes your life easy and their own life easier at the end of the day on writing proof of concept? Any tips for them on how to do better?
Yeah, so I think one of the main things is just like when you're writing your proof of concept, right? Effectively, you want to write it as if you're actually writing a smart contract that you would launch, right? So that means having good, code comments, breaking your code blocks up, general like good programming hygiene, right? Making use of functions and stuff like that, because that really allows us to kind of see your code, right? Because if you give it something and it's hard to read, or it's got like a whole bunch of spaghetti code, or it's got a whole bunch of setup, and the setup app actually like obscures the exploit, right? Then it makes it more difficult for us to triage and to understand like what it is you're trying to do. And so like especially emphasizing like the exploit part, like even just like visually breaking it up, right? And saying like, this is the part where we actually interact with the protocol. And, we have these post conditions, right? Highlighting your post conditions about the state of the smart contract. I actually say, and this is the reason why there's an issue, because, now the state is in an, unpredictable, whatever the outcome is, right, is different than what we would have expected the outcome to be. And that's the part that actually is the exploit, right? Everything else is just like the setup and the teardown. And so that's really the piece that we want people to kind of focus on and highlight in their proof of concepts as a whole. And then one other point is something that tends to grab our attention the most is that instead of using mocks, right, a lot of people, like I said, they'll kind of see this really complex piece, and maybe it's in the middle of this sort of sequence, right? And they think, oh, well, instead of trying to align the sequence up, I'm just going to pull that, piece of the smart contract logic out, and I'm going to stick it in the mock, and then I'm going to run it through the mock so that way I can get to it really easily. I would say definitely, like a lot of times people tend to mock incorrectly, right? And that's something that we've seen that makes a potentially valid report with a potentially valid proof of concept into an invalid report, right? It's like you've done something incorrect when you're actually trying to pull that out, right? Is that like instead of trying to do the mocks, to actually just do like fork tests, right? Here's the address of the smart contract on the chain. We're going to use that to call into, and we're going to call into it from the correct entry points and the exit points, and we're basically going to be able to see at that point like the actual state of the smart contract fork test. Like that's in our case, like the most ideal proof of concept.
I love these tips. I love particularly the tip on avoiding mocks and relying more on forks. There is no excuse as a secure researcher not to do that, because Foundry makes it so simple. You should be able to explain any exploit on chain, in my opinion, by just a fork test. You rarely have to use a mock unless you have a lot of heavy off-chain components. So if you are mocking something, there better be a valid reason for doing that, as opposed to like go to a state where the default is forking as opposed to mocking. Great tip. Uh, one so something to add from what I've seen is I have seen consistently like what makes great security researchers is their ability to explain a security finding in simple terms. And this also translates very well to explaining anything in simple terms. So try your best to explain your bug in really simple terms. Explain some of your assumptions. What assumption did you make? This can be often a simple way to quickly understand whether the finding is real or not. Maybe you made an assumption that is not valid. Maybe you assume that this role can be anyone when it's a trusted role. So really try your best to document your assumptions when you are writing down a submission. And I've noticed some of the exceptional security researchers also try to draw a simple picture or a diagram to explain the bug. That's a very simple way for everyone to quickly understand what's going on. So try to document your assumptions, try your best to visualize the bug with a simple picture, try to explain the bug in less than 5 lines. That's the gold standard. If you can do that, you truly understand your bug and you're truly enabling the reader to also quickly understand it. That's like an art form that you should try to master if you're a security researcher. So moving on, we talked about how a great submission looks like, and I want to maybe go to the opposite. What do you think many submissions get wrong? Are they like lacking technical depth? Are they lacking clarity? Are they lacking some structure? Like in your opinion, reading a lot of the invalid submissions, what do you think they are missing?
Yeah, so I think from the submissions that we have seen like thus far, right, I think it's definitely been like the technical depth that tends to derail like the reports. And so, most of the time, and this is, somewhat due to LLMs, right, is that the report part, the actual like writing part generally looks plausible. I would say in most of the things that we receive now, right, it's like, that sounds plausible, right? What they're saying, it's good enough, right? But when you get to the proof of concept, if there is one, right, that's where things really fall apart technically. And so what we have seen is that we can generally map like the invalid reports into two categories, right? We have the misuse of the Foundry cheat codes and the misuse of the mocks. We've already talked about it, but I think it's really important to emphasize and get across, right? Is that like Foundry cheat codes are great for setup. They're great for like getting fork testing, but they're really easy to misuse and mislead you in thinking that your proof of concept works, right? Like using pranks on certain addresses, and actually the address is a trusted address, right? So you're not going to be able to assume that the message sender is going to be that address, or doing things even like etching state into the contract, right? Like these are things that are not viable. There are no cheat codes that exist right in Foundry that are actually going to work in an EVM. And so I think minimizing the amount of cheat codes that you use to like the bare minimum, right? So just to avoid like having to actually set up an address to actually send them through, right? Like that's probably the amount of cheat codes that you should be using in your system. And maybe if you need some sort of like to like deal yourself tokens, right? Like that's maybe the part where I would like draw the line on like acceptable cheat code usage, just to make sure that you don't end up with a proof of concept that actually isn't working. If we took all the cheat codes away, like if you put your finger over them, would your proof of concept still work? Yes or no? And in the cases we have seen, the answer is no. And then back to mocks, right? It's that people, they look at the system holistically and then they try to replicate it and they try to pull out the piece, right, that's vulnerable, and they stick it into a mock effectively. But really, you're just kind of hurting yourself in that regard, because when we're triaging and reviewing, we basically have to take your mock and put it back in to the code, right? We have to fit it back in and look at it again holistically. And so that takes time. And then as we've often seen, people oversimplify the mocks, they oversimplify the contract logic, and then it turns out that their proof of concept is invalid overall.
Great tips. I love that how pragmatic you are in this conversation. I think there's a lot of great nuggets that any security researcher can understand and make themselves better as a hunter, finding bugs on chain. And this brings me to my next question. What would you tell a very talented security researcher that try to find a bug, and realize that at the end it wasn't valid. It can be pretty demoralizing. What would you tell them if you were to give them one-on-one advice?
Yeah, for sure. And I've definitely been on that side before, right? It's really, especially when you feel very strongly about a report, right? And then it comes back and it's invalid, and it's pretty, demotivating. You're like, oh, am I doing this right? Am I, even understanding this stuff correctly? Should I just stop? I'd say, first and foremost, like, don't give up. Keep going. Keep grinding towards your goals, right? Because it only takes one, right? The max reward is very high for a reason, right? And so if you find that one crit in our tier 0 system, right, you're going to get rewarded for it. So keep that in mind, but also make sure that like you kind of being realistic with yourself when you approach these bug bounty programs, right? Especially if you're going to go at like our highest complexity systems, right? Is that you're not really going to be able to sit down over a weekend and read it and find a crit, right? If you do that, again, this is where the technical depth is going to bite you, right? Because you're maybe not understanding a component, or you're going to fall into the traps, like we said, about foundry cheat codes and mocks. You're going to try and pull it out of the system, and you're going to make an assumption that's not correct, and then you're going to create an invalid finding. So there's that piece as well. Like keep going, but also be realistic with yourself. And then also, like I have found that the Cantina triagers are really good about giving feedback, and we as well try really hard to make sure that we actually explain what the issue is, right? If somebody's had an incorrect assumption, we try and write down what the assumption they made was. If the part of the proof of concept was using a cheat code and it was invalid, then we're going to write that down for them. And so what I would say is like take the time to actually look at the result, right? Don't just, if you look in your inbox and you don't even open it up and you see a report is marked invalid, some people will just like not even read the comment, right? Definitely read through it, right? Because there's going to be nuggets in there for you to like glean, right? And especially like themes, right? So if you have put in like 5 reports to the same, smart contract in a bug bounty, right? And all of them were kind of thematically about technical depth, then that tells you something, right? As a researcher, that you need to spend more time to actually go through the code. Or if there are other pieces like you're over mocking or overusing mocking, like that's the time to maybe take a step back and work on those areas as well. Like improve your skill set in that area so that the next time that you put in a report, it's actually going to be valid.
These are awesome tips, and I love a couple of the points that you mentioned. And to add a few more points, when I talk to a lot of successful bounty hunters, there is a clear pattern where they tend to look at a certain asset or a certain scope for a very long time, and sometimes like over and over again. So this also is like a hallmark of a good bug bounty program, where are you creating an environment where someone might not find something for the first time, but then they keep coming back to look for even more findings. Um, and many successful bug bounty hunters, they don't give up quite quickly, in the sense that when they look at a scope and they don't find something day one, week one, week two, week three, they keep going at it. They keep going at it until they really understand the system, and then really try to find a complex security bug. And Coinbase bounty is especially interesting because it's a very large scope. There's a lot of things that you can look at. There's a lot of interconnected components. So even if you did not find a security finding in one component, that understanding is going to help you maybe find a very tricky bug across different components. And beyond that as well, I think as an intellectual exercise, like the things that Coinbase is building today is where the industry as a whole is going to go. So if you want to level up yourself as an engineer or a security researcher, I can guarantee you that the time that you spend on looking at Coinbase asset is going to reward yourself in the future, whether it's from Coinbase itself, or you building your own startup, or you finding security issues in similar assets that people are going to build. This is where the industry is going. There is no way. They're like, the time you invest in this bounty is like time well worth it, even if you don't find any bugs. So go into it with the mindset that you're here to learn, and you're also like here to earn, whether it's from Coinbase or externally. So this is like the perfect bookkeeping program to also like level up your skills. So moving on to my next topic. This 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 that this hits like one of the points that I mentioned earlier. Like great security researchers tend to keep coming back and looking at um, the bounty the bounty assets like multiple times. What is, in your opinion, submission behaviors that would allow your team to build confidence in a certain individual? What do you look for in someone that is keep that comes back for more and more findings? What are signals for you?
Yeah, for sure. And this is just gonna be like a recap of everything that we've kind of talked about at this point, right? It's like making sure your reports are really easy to understand and that like the actual wording is very concise, right? Having your proof of concepts that are very well written, again, avoiding the mocks in your system, making sure it's well documented, well commented, emphasizing the exploit, emphasizing the post-exploit outcome that shows that the exploit has happened. And then one of the points that you had mentioned earlier, which really resonates, is stating your assumptions in the system, right? That is a piece that it can be very difficult and actually makes, triaging very time consuming, right? Is that we can't read people's minds, right? So if there's like an implicit assumption in a system, it can be hard for us to kind of determine what that is or what it is that the researchers saw, right? What they saw that made them think, okay, if X happens, then Y outcome will happen, right? And so stating like, oh, if we have assumption A and B and C in a system, right, that we think that together or an aggregate that creates this risk that we think could manifest into this exploit, right? That makes it really clear and easy for us to understand and triage. And so that even if your report is invalid, right, it makes it very easy for us to understand and triage it, which is very welcome, right? And because these reports are in good faith, right? Their best effort. We're not going to fault people for giving us reports that turn out to be invalid. That's the best outcome, right? Is that we have people looking at our system and that they're trying to dig into it and that they're working towards a case where they might actually be able to locate an issue in our system, right? And that's really all we're looking for, right, with our bug bounty program is being able to understand these conditions and catch bugs.
That is awesome. And I also want to emphasize to any secure researcher listening, if you want to win in the long time horizon, you also have to really work well with your customer, like over and over again. So this is not a one-off. You find one bug, you make $5 million, and you just go watch sunset. Like you are likely going to keep doing this over and over again. So it's very important for you that you are able to come in here and explain value to Cantina and to your customer on like on what you see are problems, and you would have to do that over and over again. And successful bounty hunters are able to do that. They're able to map out not just some vulnerability that they found, but they're also like able to explain impact very well. And this goes to my next question, which is, what has been your observation on how secure researchers explain impact? Do you think they inflate severity? And why is severity even an important metric that we attach to a submission?
Yep. So yeah, do researchers overstate severity? I would say yes. But I would say that it tends to happen in specific like vulnerability categories, right? So if people are looking at things that have a likelihood that's hard to define, or they're looking at things from like a best practices standpoint, they tend to kind of, I would say, overflate severities associated with vulnerabilities like that. And so I think sometimes people, when they have maybe less tangible evidence in those regards, that they feel like they need to add this sort of justification. And so if they feel like they can't justify it by the likelihood alone, then they have to justify it in terms of severity. So sometimes we see like an overcompensation rate of severity. And then there's in other cases where I think people are just trying to, like cut through the noise, right? They think, oh, well, there's so many reports, I really want to cut through. I want them to read it right now. And so they kind of will inflate the severity rate, like critical severity. Even in the report title, we'll see sometimes like critical severity issue, right? And all of that is kind of feeling like they're trying to shout to us, they're trying to communicate to us. And so what I would say to that is like, we get to all of our reports, right? We triage everything that comes through, and we have a pretty good like turnaround time, right? It's like sub 24 hours. It's even less than that, but I know for a fact that turnaround time is less than 24 hours. And so we're going to get to your report. And so there's no need to maybe try to flag it to us in a way by overstating severity, because that's just going to affect the outcome of your report as a whole. And then there are a couple other cases that we've seen overstated severity, generally like around non-trivial preconditions, as we would call them. So this is, again, like where stating your assumptions is really important. So if your vulnerability requires like user error, right, or administrative user error, right, like that is something that definitely is like in the like likelihood range of like, we're not entirely sure if that's going to be plausible or not. It definitely could be plausible, but stating your assumptions there on what conditions you think need to be in place for the user error to occur is like really important to being able to like match your impact, right, to match your overall severity. Otherwise, if we're seeing like this really high severity, and then you aren't explaining your likelihood, you aren't explaining the assumptions that could lead to this high severity, then it's not really going to turn out in your favor. And so why does severity like matter, right? Like, why do we do it? Why do we even gauge for it, right? It's important from like a triaging perspective. We need to know, right, if we need to take action immediately, although technically at this point, if any report turns out to be valid in our program, we would actually just start an incident regardless, because we consider any sort of like smart contract audit change to be like out of band. So they all get treated the same way at the end of the day for us. But it's definitely important for us to understand like how we need to act and how we need to operate, to mitigate and fix bugs like that. So severity is really important in that case. But also, like, overstating severity can be very dangerous from like a triager and researcher perspective, right? Because it could create bias. It could create bias towards the researcher, and it could even create bias towards the vulnerability category. And that's not what we want, right? And so going back to the example about like administrative user error, it's entirely plausible that that's an issue, right? Like if the front end, if we're talking about a holistic system, and we have a front end that's misleading, and the back end is a smart contract, right? And the front end would actually mislead an administrator to do something incorrectly on the smart contract, then we truly do have a bug in our system that we need to fix, right? But if we're seeing all of these, 9 times out of 10, somebody is overstating, user error, that could create bias overall, and that's very dangerous, right? Because when we view bugs and reports, right, we want to view them holistically through the same lens, consistently, repeatedly, every time, because that's what makes triaging effective, right? And so anything that could change how we view reports and change our consistency, right, are things that we need to be very mindful for, because that's an outcome that we don't want. So we actually, we say that something actually isn't an issue, and it turns out that it is an issue. That's like the worst case scenario.
This is great advice, and something that I can talk about, as we've seen in various different programs, is like smart contracts bugs, when they're severe, they often need to be addressed immediately. We have seen several instances where when a customer realized that one of the findings is critical, which often means there is dollar value on chain that can be stolen by anyone. If that is the case, you need to act ASAP. And the time to fixing that issue is so critical. We have seen instances where people were able to quickly fix and either white hat the money out or like push a fix. So going from a critical finding that puts dollar value on chain at risk to a fix and shortening that time to like as short as possible is such an important thing. And like I've seen examples where it went really well and really poorly. So this is why like you as a security researcher also need to build a bit of empathy towards the other side, where if you are saying that something is critical, you are expecting the customer to immediately like jump in and fix the issue, and you don't want to like burn that bridge multiple times by submitting something that you claim is critical, but requires maybe like a user to do something that they usually don't do. So be very conscious of your customer at the end of the day. And if you are saying something is critical, like your expectation should be that they are going to jump in and fix it immediately. And that is a very stressful process for everyone involved. And we have seen that happen really well and really poorly. And pay attention to how you um, put severity on your findings. And we touched on this topic a few times. Coinbase bug bounty is very expansive, and there is a lot of assets. So tell me more about what assets are in scope. What are some of your favorite assets that you believe secure researchers should pay more attention to? If you were a secure researcher, what would you be looking at? Looking for bugs. Any tips that you want to help hunters?
For sure. And so I think, and we've talked about this before, right? Coinbase's bug bounty is large, not only in terms of the magnitude of the max payout, but also in terms of what's in scope, right? I think it might actually be the largest in terms of all of the smart contracts that we have in scope. And that's something that I know when we initially launched, I don't think we did as good of a job kind of explaining, right? So a lot of people tend to focus on our tier 0 smart contracts, right? So that's Base and CBE and CBBTC, right? And then in tier 1, effectively when we launched, it was like, and everything else. But we didn't really kind of go into detail there. And that's something that we've worked with your team on, is actually kind of going through and properly expanding on just everything, every smart contract, every address, right, that's in scope. And so, I really want to emphasize, this is one of the main points that researchers take away from this talk, right, is that in tier 1, there are a lot of smart contracts, and that list is ever expanding, right? So, the largest bug bounty payout would go to the tier 0, but even in tier 1, we're looking at like $500,000 max payout, and that's not, spare change either, right? And so there's a lot of opportunity there, right? We have like base names, we have the other like CB wrapped token assets, right? We have ENS contracts, we have smart wallet infrastructure, we have like DEX aggregators, and we even have like a batch deposit contract that we use for post-Pectra ETH staking, right? So I have a whole breadth of smart contracts in scope, and it's just ever expanding, right? So for instance, when we acquire companies, right, and they have smart contract on-chain components, like that's going to also go into our bug bounty program. So definitely, if you look at it now, it's not static. Keep looking at it. It's going to expand, throughout the years, and just kind of keep growing in terms of size and opportunity as a result.
This is a good tip on particularly acquisition. Like Coinbase has been acquiring a lot of companies. I think today we saw the news about Coinbase acquiring Echo. So what does that mean for a secure researcher? Like, should they consider Echo to be now part of the Coinbase bug bounty as well? Should they be looking at it like today? Like, when should they be looking at Echo smart contracts with the expectation that Coinbase will be providing bounties if they find security bugs?
Yeah, so for sure. And so that's basically one of the things that we do when we're trying to integrate, new companies, right, into Coinbase, is that from a security standpoint, there's a lot of things that have to happen, right? And one of the things on our list is basically making sure that we understand all of the smart contracts that they have in scope, and then we add them to the bug bounty program. And so we also did this with Liquify. Liquify was another acquisition earlier in the year. They have also been added to the bug bounty scope. And so that's going to happen, I would say, within a couple of weeks. Basically, as soon as we can figure out all the smart contracts, right, and get the list of all of them and double check them off with the engineers, we will add them to the bug bounty scope.
This is a highly underrated tip that I think people are not talking about, and Coinbase might be in a unique position because they are large enough to acquire a lot of other businesses. So definitely, like, if you're listening in, pay attention to the companies that are getting acquired by Coinbase. Maybe they don't have as good of a security practice as Coinbase internal team have, and that is opportunity for you to find bugs. So, like, if I were a security researcher just listening, I would immediately jump into some of these acquired assets and see like if we can find bugs.
And another point, in terms of like dynamism, right? It's not just like in terms of acquisitions, right? But even for like Base, right? Like every time there's a hard fork, right? Every time we have a major upgrade to base, there's new opportunities, right? Every time we do a protocol upgrade, there's new, if you think you've looked it over and you're not going to look at it again, I would say, rethink that position, because every single time we have a hard fork, every single time there's a contract upgrade, that presents a new opportunity, right? For you to basically go back in and double check and make sure everything looks okay.
Okay, this was very wonderful. And I want to ask you one final tip to secure researchers. And if you were to give them advice on what to look for from your point of view, that would enable them to find like security bounties, what would you say to them? Like, if I were a new security researcher or an experienced one, what should I be looking at?
Yeah, so I would say, like we have a whole, like we mentioned, we kind of went through it. We have a whole breadth of different products and opportunities and smart contracts for you to look at. I would say, maybe just pick, the thing that interests you the most, right? And start there, right? Because there's a lot of things, and some of them are going to be more complex than others and less complex, right? So, aligning your research to things that personally interest you, right, is going to make you want to dig into it more and understand it more, and maybe kind of be able to use your background to your advantage to be able to locate, bugs a little bit easier, right? But again, so there's that piece, and then going back to what I said earlier, right, is that like we have so many things in scope of varying degrees of complexity that you're not going to find bugs in a day, right? You're not going to sit down and be able to just, get a crit like that, right? So definitely give yourself time to understand as well, and time to build up that knowledge overall. Because like I said, dynamic programs, right? So you build up knowledge now, in the future when there's a change, you've got this knowledge base to lean into, right? So think of it as like an investment into the bug bounty program, like long term, right? Is basically like it's like bug bounties are kind of a mix of skill and opportunity and timing, right? So as you build your skill and you build those opportunities, right, at some point the timing is going to be in your favor.
This is awesome advice, and I 100% agree with what Alexis just mentioned. Like spending time on Coinbase Bounty is probably one of the best investments that you would make from a learning point of view and from an opportunity point of view. Even if you cannot find bugs in Coinbase's own scope, there's like tens of hundreds of protocols that are quite similar, because Coinbase tends to build in like markets that they believe is the future, and there'll be more players building similar products and services. And maybe you don't find a bug in the Coinbase scope, but your understanding about Coinbase's product will enable you to find bugs in other programs. So 100% look at this bug bounty as a learning exercise, and a way to challenge yourself to find bugs, whether it's in Coinbase or elsewhere. I know we have less than 10 minutes left. I will let you ask any questions before we wrap up, Alexis. Like, any questions for me? Any questions on Cantina? Any questions about what we see?
Yeah, I think I just would like to learn a little bit more about like how you guys are approaching like triaging, right? Like I know we're working together on a few things. We've added some, I think we even added like a severity detector as like a little debug thing, trying to go through automation. I think you talked about it a little bit at the start, but definitely something that interests me, right, is like what kind of automation opportunities are you seeing overall for bug bounty programs, for audits, for research, everything?
This is a great question. And the reality of being a bug bounty platform, or a platform where anyone can come in and submit findings, is a significant portion of that finding is not valid. And your job is now to figure out the signal from the noise. And this is not easy, because um, everyone talks about, everyone across the security industry, they talk about figuring out security signals, but there is also that alerting fatigue that you have to optimize for. So if you are just optimizing for like getting all the signals in, you may not be able to act at a time when you have to act on the signal. So you really have to also optimize for what is your signal and what is your noise. So a lot of the work that we put in on our system is, how do we make sure that, like, when there is a serious finding, we can really get our customer to respond to it and understand it and fix it as soon as possible and avoid any customer funds from getting lost. So we care very deeply about this, and we are also building some systems where if a triage thinks that this finding is really, really critical, then there is a way to immediately alert the customer, not just from a regular notification, but like like they should understand that there is potentially something that could kill their protocol. And we've had multiple close calls in the past where there was a critical finding, and we realized that a customer money is on the line if they don't act. And we've had very successful white hat recoveries where, for example, in Panoptic, I think there was $4 million in TVL that was at risk that anyone could steal, and we realized from a bug bounty submission that this is true. And over the course of a couple of days, we were able to, one, get a lot of their users to withdraw the money, and two, white hat the funds and redistribute them back to the users. So this is like the reality of crypto security, where the amount of money at risk can be pretty significant. And when you see that something is valid, you have to optimize your process to take an action, and sometimes like on-chain actions. So a signal to noise ratio, in summary, like that is the most important thing for us. And then once we have the signal, like getting people to take an action, that is the second most important thing for us. On the signal to noise ratio part, for the very first time in history, these LLMs and these agents are capable of truly understanding what is going on with the finding. And we have some internal deployments for, I think the last benchmark we ran, like we took a data set of 315 findings from a competition that were marked as high or medium by the secure researcher. And then we compared them to one of the agents that we were building that can understand a submission and can tell you whether it's valid or invalid. And then we also have the data set on whether a human thinks it's valid or not, a human judge. Then an agent and a human was able to agree on the severity, on the validity of the finding for more than 95% of the submission, which, if you told me like a year ago, I would have said this is impossible to build. But there is clearly breakthroughs in LLMs, these agentic systems, there's reasoning models, these models being able to use tools, and these models being able to follow instructions very well, that allow us to build products that just wasn't possible before. So now our challenge is, how do we tune some of this early agent work that we've done? How do we deploy them in a safe environment? Because that's the other potential risk. We don't fully understand LLMs from a safety point of view yet. So we have to also put in some work on before we deploy any of this agents into systems that are already live. We don't want that to be another attack vector. So we deploy them internally on assets where there is no money at risk, oftentimes competitions before they are launched, because there is no money at risk at the end of the day. But before getting to deploy them on Coinbase, which has billions of dollars on the line, we have to do our work on making sure that these systems can't be abused either. So that is, I think, where the industry as a whole is going. How can we reduce the time that Coinbase's team, our team, have to do understanding findings? And for the very first time in history, this is possible. It wasn't possible a year ago. So that's from my point of view and where the industry is going.
Gotcha. Yeah, that's very insightful, and I especially like the 2 points, kind of key points. I think take away from that is like the having proper escalation pathways, right, cross company is really important, because a lot of times people don't realize that they don't have it until they need it, right? And all of a sudden you've got a really critical issue and you're trying to flag to the person, you're trying to text them and they're not responding, right? And so having a better process overall for basically being able to respond in sub minutes, right? Because that's basically at that point, when you have a critical issue, it's valid, it's minutes at that point that you need to start responding to the issue, right? So that piece, very important. And then the piece you mentioned about data safety of LLMs, right? Often overlooked, very critical, right? We don't want to feed all of this information to an LLM. And then, in a public audit competition or something else, right? It starts spitting out a bunch of, sensitive information, or it spits out like an active report, right? That would be very, disruptive and potentially dangerous, right? From the bug bounty perspective.
100%. I think there's the data safety and the ability for the system to be abused as well, that we have to put in our work before we deploy them to like production. On the data safety, at least, like many LLM providers today have very clear guidelines on how you can get the best level of safety, where they won't train on your data, they keep your data private, and sometimes even you can build the systems where the data is inside your own systems. So there are several levels to get there, but at least like this is a direction that, as an entire like industry, the AI companies are trying to solve. Where what data can they use? Who can see the data? Can they train on the data? Where can you contain the data? This we can borrow from the existing AI industry, but my personal concern is like we don't fully understand the system and their limits and how they can be abused. And LLMs today can be abused heavily, and that is something we have to consider before we deploy into any sensitive bounties. Like with Coinbase, there is billions of dollars on the line. I do not want the LLMs to be exploited to like leak information or take it to make it do actions that it should not be doing. Like we are very conscious of that as we are deploying into real mission critical software. I think I had something else in mind that you mentioned, which is anyway, I think I forgot what I had in mind. But this was really wonderful, Alexis. I think I learned a lot. I'm pretty certain the listeners listening to this, hopefully secure researchers, learned a lot, and they can, they should be able to learn a lot about Coinbase, your software, and where the industry is going by looking at the Bounty. There's a lot of really good tips that Alexis mentioned that should like dramatically change the outcomes of secure researchers. Thank you once again for doing this. And if you're a secure researcher listening, this is your opportunity to go hunt at the Coinbase Bounty program. It's accessible for anyone, and the rewards are life-changing amount of money if you can find that one single finding. But even if you don't, greatest way to learn. So thank you for listening in, and thank you, Alexis, one more time for sharing all this wisdom.
Yep. Thanks again for having me. And to all the researchers out there, happy hunting.
Awesome.